Hey, welcome. Have you ever felt completely lost, even with a phone in your hand? Well, today, we're going to unlock a skill that's part art, part science, and honestly, just essential for really understanding the world around you: reading a map.
See, a map isn't just a drawing. It's a coded message, a whole story about a place just waiting for you to read it. And over the next few minutes, that's exactly what we're going to learn how to do. We're going to learn that secret language.
So let's start with the absolute basics. What even is a map? At its core, it's just a picture of the Earth's surface, or a piece of it that's been shrunk down to a specific size, or scale, to fit on a flat surface, like a piece of paper. Think of it like a perfect bird's-eye photo of an area that can fit right in your hand.
And map reading, well, that's simply the skill of looking at all those little lines and symbols and knowing what they mean. It's a visual language, really. And once you learn the vocabulary, a whole new layer of information just opens up to you no matter where you are.
So, here's our game plan for this explainer. First, we'll look at how there's a map for every mission. Then, we'll decode their secret alphabet of symbols. After that, we're going to tackle the most important part, the power of scale. And finally, we'll bring it all together. Ready?
First up, not all maps are created equal. You gotta know that they're specialized tools, with each one designed for a very specific job.
Let's kick things off with the real workhorse of the mapping world, the topographical map. If you need details, and I mean real details, this is your go-to.
Topographical maps are amazing. They pack an incredible amount of info into one place. They cover a smaller area, but do it on a large scale, which means they can show you everything from rivers and forests to roads and buildings. But here's the coolest part. Those squiggly contour lines, they actually let you see a three-dimensional landscape, hills, valleys, and all, on a totally flat piece of paper. It's how a hiker knows if a trail is about to go steeply uphill, or how an engineer knows the best place to build a new road.
Now, on the other end of the spectrum, you've got your atlas maps. These give you the big picture, like a whole country or continent, but they sacrifice a lot of detail to do it. And then you have sketch maps, which are just quick, freehand drawings that aren't to scale, and plan maps, which are super detailed, large-scale drawings for one specific thing, kind of like a blueprint for a house.
Okay, now that we know about the different kinds of maps, let's get into their language. It's time to learn the map's secret alphabet.
These are what we call conventional symbols. Cartographers, which is just the cool word for map makers, have created this whole standardized set of signs and symbols to represent stuff in the real world, whether it's something natural, like a river, or something man-made, like a bridge.
And they basically fall into four main families. You've got your line symbols for things that stretch out, like roads or boundaries. Then there are point symbols for specific spots, like a single building. You also have pictorial symbols, which are literally little pictures of things. And finally, literal symbols, which are just simple letter abbreviations.
This is a perfect example of how efficient those symbols are. I mean, think about it. Instead of trying to write out the full word school and cluttering up the map, a cartographer just puts SCH. It's a clean, simple shorthand that lets them pack a ton of information into a really small space. Okay, listen up, because this next part is maybe the single most important concept in all of map reading. It's called scale. This is the magic that shrinks the entire world down onto a piece of paper, and we are going to break it down step by step. So at its heart, scale is just a ratio. It tells you exactly how a measurement on the map relates to the actual distance on the ground. You can think of it as the map's zoom level. And maps usually tell you this ratio in one of three ways: a simple statement, a more universal representative fraction, or RF, and that little ruler you see at the bottom, which is a graphical linear scale.
A statement scale, like 1 centimeter to 1 kilometer, is super easy to get your head around, but the representative fraction, or RF, is actually way more powerful. A scale of 1 to 50,000 just means one unit of anything on the map equals 50,000 of that same unit on the ground. It could be inches, centimeters, whatever. It's universal, and that's the key.
And that third type, the linear scale, its biggest advantage is a huge one. If you ever enlarge or shrink a map, like on a photocopier, the written scales, like the statement or the RF, become totally wrong. But this little graphic bar, it shrinks or grows right along with the map, so it always stays accurate. Pretty smart, right?
So this is where the real power comes in. Being able to convert between these different types of scales is what unlocks the true potential of any map you pick up. So let's actually walk through how to do it.
All right, let's crack this code. Say we have a statement, 1 centimeter to 1 kilometer. To turn that into an RF, the only rule is that both sides have to be in the same unit.
So let's use centimeters. We just need to know that 1 kilometer is 100,000 centimeters. So our statement becomes 1 centimeter to 100,000 centimeters. Now just drop the units, and there's your RF, 1 to 100,000. See? Simple.
Now let's go the other way. We've got an RF of 1 to 50,000. What does that actually mean? Well, it means 1 centimeter on the map is 50,000 centimeters on the ground. But nobody talks like that. So let's turn that ground distance into something useful, like kilometers. We just divide 50,000 by our magic number, 100,000, and we get 0.5. So the statement is 1 centimeter to half a kilometer. That's so much easier to picture. Seriously, if you remember one thing from this whole section, let it be this number, 100,000. There are 100,000 centimeters in a kilometer. This is the magic number, the key that unlocks all of these scale conversions. Burn this into your brain, and you'll always be able to figure out real distances from any map.
And there we have it. We've gone from what a map is all the way to the details of scale conversion. You now have the foundational skills for what I like to call your new superpower, map literacy. So let's quickly recap our new toolkit. We know that maps are just scaled-down pictures of the world. We know that different maps, like topographical or atlas maps, have different jobs. We can speak the visual language of symbols, and most importantly, we get that scale is the crucial link between the map and reality, and we even know how to convert it.
So the next time you pick up a map, remember, it is so much more than just lines on paper. It's a coded document, a story of a place, and you